All right, so get this. Imagine telling your computer what to do, like book a flight or research a new recipe, and it just does it.
Yeah.
No clicking through menus or endless scrolling.
Uh-huh.
That future, that's what GUI agents are building, and that's what we're diving into today.
It's pretty wild, right? We're basically teaching AI to use computers just like we do.
Huh.
Clicking, typing, scrolling. It's like they're becoming masters of the digital world.
We've got this research survey here. It's jam-packed with info, but I gotta be honest, when I first saw GUI agents, I thought it was straight out of sci-fi.
I could see that.
What exactly are GUI agents?
Okay, so a GI agent is basically a software robot that can interact with any digital interface.
Okay.
Like your desktop, your phone, a web browser, just like a human. It can see what's on the screen, figure out what everything is, and then take actions to actually get things done. All without you lifting a finger.
So basically, it's like having a super efficient digital assistant that can handle all that tedious stuff we do online. Sign me up. But, and here's where my brain starts to melt a little, how do these agents deal with the visual chaos of, like, the digital world that we made? Unlike traditional AI that works with nice, neat data, GUI agents got to handle all those icons and buttons and menus.
That's one of the biggest challenges, yeah. And it all comes down to what we call the perception interface.
Okay.
It's basically how the GEO agent sees and understands the digital world,
Yeah.
like giving it different senses, you know?
I'm starting to see the picture here. So are there different types of perception interfaces?
You got it. One way is to use the operating system's accessibility features.
Interesting.
They're already built into our devices, and they provide this kind of semantic understanding of the interface.
Mm-hmm.
So they tell the agent, like, hey, this is a button, this is a text field, this is what they do. It's clever, right?
Yeah, it's a clever way to leverage existing technology for sure.
And it's more privacy friendly. No need for the agent to actually see the screen visually.
That makes sense. But what about websites? They're so much more complex, always changing compared to like an app.
You're right. Websites are a whole different beast. That's where HTML DOM-based perception comes in.
Yeah.
Websites are built with HTML, right? So this approach basically analyzes that structure, kind of like a blueprint, to identify stuff and understand how it all fits together.
So it's reading the code.
Exactly. The challenge is that raw HTML can be super messy, lots of redundancy.
So it's like trying to find a needle in a haystack of code.
Pretty much.
Wow.
Researchers are coming up with ways to clean that up, but it's definitely tricky.
Okay, so you got accessibility features for understanding the meaning, HTML for websites. What about just plain old computer vision? Can't the agent just look at the screen and figure it out like we do?
We can do that too, and it's getting more and more powerful with all the advances in image recognition. We call this screen visual-based perception. The agent processes screenshots to locate and identify elements. But it does raise some privacy flags. Capturing everything on the screen, it can get a little iffy.
I can see how that would be a problem. You don't want your agent accidentally snapping a picture of, like, your online banking.
Exactly. A lot of developers are going for hybrid approaches, combining all of these. Accessibility features, HTML, a little bit of visual processing to create this really robust system, like giving the agent multiple senses to make sure it's interpreting things correctly.
That's super clever.
Yeah.
So the agent can now see, but how does it know what to do?
Right.
It's not just randomly clicking around, right?
Nope, definitely not. That's where the reasoning and planning comes in. Once the agent understands the environment, it has to figure out, okay, how do I reach this goal? That goal could be anything from booking a flight to writing an email.
So let's talk about the brain of these GUI agents for a sec.
Okay.
Are they just following pre-programmed rules, or is there something more sophisticated happening?
It's definitely more than just rules. The old ways of planning symbolic AI, which relies on very strict handcrafted rules or basic reinforcement learning, which needs tons of data, well, they're not really cutting it. We're seeing a shift to using large language models, or LLMs, as the brains of these agents.
Wait, LLM, those things that power ChatGPT? So
Yeah.
it's like the LLM is the brain, the GUI is the body. LLM thinks, GUI acts.
Exactly, you got it. And that opens up so many possibilities.
Wow.
With LLMs, they can process info, reason logically, and even understand natural language instructions, just like you'd give to a human assistant.
So we're essentially giving them the ability to, like, think and learn like us.
Pretty much.
That's both exciting and a little scary. But you mentioned internal knowledge and external knowledge planning. What's the difference?
Good question. So planning with internal knowledge means the agent uses what it already knows to come up with a plan. Imagine an agent that can actually simulate the outcomes of its actions before it does anything.
Like a chess player thinking several moves ahead.
Exactly. There's a system called WebDreamer where it creates this virtual model of the web and then dreams about different actions, seeing what would happen before choosing the best one.
Whoa.
It's pretty amazing.
It's like it can imagine different futures. Okay, that's internal. What about external knowledge? Does that mean it can search the web for info, kind of like we do when we're trying to solve a problem?
Exactly right. They're not stuck with just what they were programmed with. They can use info from the real world,
Sure.
like if you ask it to plan a trip to Hawaii. It could search for the best flights, compare hotels, even read reviews to make the best plan for you. There are agents like Search Agent and Web Shop that are designed specifically for this kind of thing.
So they're learning new stuff on their own. That's incredible. But how do they actually do anything with these plans? How do we get from an abstract plan to actual mouse clicks and keystrokes?
Ah, that's action grounding.
Okay.
And that's where things get really interesting. In the world of GUI agents, that's where the rubber meets the road.
Let's get into it then. How do they bridge that gap from thought to action?
There are a couple of ways. One is to rely on textual interfaces, using stuff like HTML tags or labels to find and interact with elements. Kind of like using a map where each element on the screen is like a landmark with a specific label.
Okay, I see. But what if the map's outdated or incomplete? What if the website changes its layout?
That's a great point, and that's where visual grounding comes in. This is where the agent maps instructions directly to what it sees on the screen, learning to associate words with actual locations.
So instead of using a map, it's learning to recognize the landmarks themselves.
Exactly.
Makes sense. But how do you teach them to do any of this? It's not like we can give them a manual and say, go figure it out.
Right. It's not that easy. Training these agents is a pretty complex process. There are two main approaches, prompt-based and training-based.
All right, let's unpack those. What's the idea behind prompting? Is it like giving them instructions or examples?
Yeah, pretty much. Prompt-based methods are all about guiding the agent without actually changing its underlying LLM. It's like giving it a nudge in the right direction.
So instead of rewiring its brain, we're just giving it some helpful hints.
Exactly. And there's this cool example called Dinosaur. This agent actually learns to create entirely new actions by, get this, generating Python code, all through prompting.
Wait, it can write code?
Yes,
That's next level.
it is. And there are other techniques like self-reflection, where it's prompted to analyze its own actions and be like, oops, I messed up. How can I do better?
So it's not just blindly following instructions. It's learning from its mistakes.
That's incredible. What about training-based methods? When do we need to go beyond prompting and actually mess with its underlying model?
Training-based methods are crucial when you want to really fine-tune the agent for specific tasks or just boost its overall performance. We're talking about actually updating the agent's, brain through different techniques. It's like sending it to boot camp. Okay, I'm ready for boot camp. What kind of training are we talking about?
Well, one common approach is pre-training.
Okay.
It's basically exposing the agent to a massive amount of data, so it builds up a solid foundation of knowledge and skills. Think of it like giving it a broad education before it specializes in anything.
Yeah, so what kind of data?
Imagine showing it thousands, even millions, of examples of how people interact with different GUIs.
Oh, wow.
Screenshots of websites and apps, recordings of user interactions, all that stuff. It's all about showing it as much as possible so it can learn the general rules of how it all works.
That's a lot of data.
Yeah, it is, and it needs a lot of power to process it all. But the results are pretty incredible. There are models like PSEX2Struct and Seqlik that have been pre-trained on huge data sets, and they're already understanding website structure, extracting info from images, even predicting what a user will do next. It's really accurate.
So pre-training is like building that powerful engine. What about fine-tuning? When do we need to specialize an agent's skills?
Fine-tuning comes after pre-training. It's about making it really, really good at a very particular task. We do this by training it on more specific data sets, ones that focus on the tiny details of whatever we're trying to teach it. It's like customizing that powerful engine to make it run perfectly in a specific race car.
Okay, that's a great analogy. So what are some examples of how fine-tuning makes a difference?
There are models like Falcon UI and UI Pro that were fine-tuned on specific GUI interactions, and they just blew the previous models out of the water in terms of accuracy and efficiency, like expert drivers who know every turn of a specific track.
Wow, this is seriously impressive stuff, but it kind of makes me think, what are the limitations here? What are researchers wrestling with when it comes to these GUI agents? Are there any risks that they could, become too powerful?
It's understandable that people have concerns, especially as they get more sophisticated. But remember, these are tools, just like any other technology. What
Right.
matters is how we use them.
That's a good point. So it's not about the tech itself, but how we choose to wield it. What are some of the specific challenges that researchers are like actively working on right now?
Well, a big one is getting better at understanding user intent. Even though they're getting good at following instructions, sometimes they still struggle to figure out what the user really wants. Human communication, it's full of nuances, and teaching an agent to get all that, that's tricky.
Yeah, it's one thing to say, book me a flight to Hawaii, but another thing entirely to get across all those unspoken preferences, like budget, dates, all that.
Exactly. And that's why people are excited about using LLMs to create these richer models of user behavior. Instead of just understanding each individual command, the goal is to predict what the user is actually trying to achieve, even if they don't say it directly.
So it's like teaching the agent to read between the lines of our digital interactions.
That's a great way to put it, yeah. And there's work being done on agents that can anticipate needs, adapt to different communication styles, even handle instructions that are a bit vague. It's like giving the agent a sixth sense for human behavior.
Okay, but what about security and privacy? These agents, they're often dealing with passwords, financial info, all kinds of sensitive stuff. How do we make sure they handle it responsibly?
Security and privacy are super important, and researchers are exploring all sorts of promising approaches. One idea is to develop privacy-preserving training techniques, so the agents can learn from sensitive data without actually storing or transmitting it in a way that could be compromised.
So it's like training on a blurred out version of the data.
Pretty much.
Yeah.
It can learn the patterns without ever seeing the actual sensitive information.
Okay, that's clever. But what about when the agent needs to use real-time data, like managing your bank account?
That's where local processing is key.
Remind me what that is again.
Sure. So it basically means running all the agent's computations on your device, not in the cloud. This way, there's less risk of breaches, and you have way more control over your info. It's like having a personal assistant that works offline.
They have the data, but it never leaves your house.
Exactly.
Yeah.
And then, of course, we need to make sure that only the right people can access and control these agents. That's why there's a lot of work going into things like biometric authentication, using fingerprints or voice recognition, to make sure it's really you giving the instructions.
That's reassuring. It sounds like people are really putting a lot of thought into building trust and security into these systems from the ground up.
They are. The goal is to empower users, not to create new risks.
This has been incredible so far. We've gone from like GUI agents 101 to talking about their brains and how they're trained. But I'm really curious about the bigger picture. What does the future hold for these things? Will they be everywhere, like smartphones? Will they change how we live and work?
Those are big questions, and honestly, we're only just beginning to explore what's possible. But one thing's for sure, they have the potential to be a total game changer.
Oh, I love thinking about the future. Let's play that game. Imagine a world where, like, we never have to struggle with a confusing software interface ever again.
Yes.
The GUI agent just knows what we want, handles it all behind the scenes.
And imagine a world where tech is truly accessible to everyone, no matter their skill level or even their physical abilities. GUI agents could help people who struggle with traditional interfaces, making the digital world so much more inclusive.
Technology that adapts to the user, not the other way around.
Exactly.
I can see them being huge in education, healthcare, even creative fields.
Oh, absolutely. Imagine students learning through these interactive simulations, guided by a GUI agent that's patient and knows a ton.
Yeah.
Or patients getting help managing their health with a digital assistant that really understands their needs. And think about creative applications. Musicians collaborating with an AI agent to compose a symphony, writers working with one to develop storylines.
It's starting to sound less like sci-fi and more like, well, inevitable. But as exciting as all this is, we also got to be mindful of the ethical side of things.
You're absolutely right. As these agents get smarter and more independent, we need to make sure they stay tools that empower us, not replace us.
That's such a crucial point. It's like we're standing at the edge of this whole new frontier, not just in technology, but in how we understand what it means to be human in a world where machines can do so much.
I like that. It's a great way to put it. And like with any new frontier, there are going to be challenges, there are going to be opportunities, but I think the potential of GUI agents is just too big to ignore.
Totally agree. It's a journey we got to take. We've covered so much in this first part of our deep dive, from the basics of GUI agents to their potential impact on, well, pretty much everything.
It's a lot to take in.
Now let's shift gears a bit and dive into the nitty-gritty of how we train these remarkable agents.
Welcome back. Before we get into the training stuff, we were talking about those challenges facing GUI agents, like understanding what the user really wants, security, and making sure these things run fast.
Yeah, those seem like pretty big hurdles, but it also sounded like researchers are already on the case, coming up with some clever solutions. What are some of the most promising approaches they're using?
Okay, let's start with user intent understanding. There's this big buzz around using those LLMs, the large language models, to create these much more sophisticated models of user behavior.
Hmm.
Instead of just, processing each command one by one, imagine an agent that can actually anticipate your needs. Like, get what you're trying to do, even if you don't say it directly.
So it's like the GUI agent is developing a sense of intuition about the user,
Yeah, that's a good way to put it.
being able to read between the lines of those digital interactions.
Exactly. Think about all those unspoken preferences and contextual clues that, we as humans pick up on when we talk to each other. GUI agents are being trained to do that too, you know, recognizing subtle signals, adapting to different communication styles, handling instructions that are a bit vague.
Okay, that's pretty cool. It's like having a digital assistant who's always one step ahead, anticipating your next move. But what about the security and privacy stuff? These agents, they often have access to things like passwords and financial information. How do we make sure all that is handled responsibly and kept safe?
That's a super important question. Researchers are really laser focused on developing those strong security and privacy measures. One promising avenue is using something called privacy-preserving training techniques. So this allows those agents to learn from sensitive data without actually storing or transmitting it in a way that could be, well, compromised.
So it's kind of like training them on a sanitized version of the data. They learn the important stuff without ever actually seeing the raw, sensitive information.
Yeah, exactly. It's like giving them a set of blueprints, but without showing them the actual materials.
Okay, that makes sense.
And for those situations where the agent does need access to that real-time sensitive data, like managing your bank account or making online purchases, there's a lot of focus on local processing.
Right, local processing. Remind me what that is again?
Sure. Local processing means running all of the agent's computations directly on your device, not on some server in the cloud.
Uh-huh.
So this reduces the risk of those data breaches big time, and it also puts you in control of your own information.
It's like having that personal assistant, but they work offline, right? They can access your data, but it never has to leave your device.
That's a great way to think about it. And of course, we need strong authentication too. We want to make sure that only you, the authorized user, can actually give your GUI agent instructions.
Okay, that makes sense. So things like biometric authentication, like fingerprints or voice recognition, could play a role in keeping things secure.
Absolutely. You need those layers of security to make sure these agents are used responsibly and ethically.
This is reassuring for sure. It sounds like there's a lot of thought going into building trust and security into these systems right from the start.
Yeah.
But let's shift gears a little bit here and talk about speed. I mean, if these agents are going to be a part of our daily lives, they're going to have to be fast, right? Nobody wants to wait forever for their digital assistant to, finish a simple task.
That's a great point. You're right. Nobody wants a slowpoke assistant. Efficiency is key, and researchers are looking at a lot of different techniques to make those agents faster.
Okay.
One way is to optimize those LLM architectures themselves. Remember those large language models?
Yeah.
Well, we can actually streamline the code, make it more efficient, and that can give us a big boost in processing speed.
So it's like giving their brains a turbo boost.
Yeah, exactly. And researchers are also looking into how to compress those models without making them any less accurate. It's a bit of a balancing act. But if we can make them smaller, more compact, then they'll run much faster, even on devices that don't have a ton of processing power.
Right, that makes sense. But what about those tasks that require a lot of, computational heavy lifting, like analyzing complex data or running some crazy simulation? How do we keep those agents from slowing down to a crawl?
That's where we can use something called adaptive inference techniques. These techniques allow the agent to actually change how much computational power it uses depending on how complex the task is.
So for simple stuff, it runs in low power mode, but for
Mm.
more demanding stuff, it kicks into high gear and uses everything it's got.
Exactly. It's like finding that sweet spot between speed and efficiency, making sure the agent is always responsive without draining your battery or, hogging all your system resources.
Okay, so we've talked about some of those challenges, how people are tackling them, but I'm really curious about the bigger picture. What does the future actually hold for GUI agents? Are we going to see them everywhere, like smartphones? Will they fundamentally change how we work and live?
It's hard to say for sure, but I do think they have the potential to be as big as those technologies,
Oh,
totally transformative.
okay.
Just imagine a world.
Oh, I love imagining the future. Let's play that game. Imagine a world where we never have to deal with frustrating software ever again.
Yes.
Our GUI agent just gets us, and handles everything for us.
And imagine a world where technology is accessible to everyone, regardless of their skills or physical abilities.
Yeah.
GUI agents could help people who struggle with traditional interfaces, right? Making the digital world truly inclusive.
Technology that adapts to the user, not the other way around.
Exactly.
I can see them being useful in so many areas. Education, healthcare, even in creative fields, like the possibilities seem endless.
Absolutely. Imagine students learning complex concepts through these incredible interactive simulations, guided by like a really patient and knowledgeable GUI agent.
Yeah.
Or think about patients managing their health with personalized support from an agent that really understands their needs and can help them navigate all that complex medical information.
And think about all the creative possibilities. Musicians collaborating with an AI to compose, writers working with one to come up with storylines.
The possibilities are truly mind-blowing. There's no doubt about that. But I think as we go down this road, it's super important to remember that, great power comes with great responsibility.
It's a good reminder, for sure. As those agents become smarter, more independent, we have to make sure that they remain tools that help us, not things that control us or take away our ability to make our own choices.
I completely agree. We need to be thinking about the ethics, talking about potential risks and benefits, and really considering the long-term consequences of having these agents in our lives. It's on all of us to shape the future of this technology in a way that benefits everyone.
I think that's a really important point. The future isn't something that just happens to us. We have a say in it. We create it through the choices we make.
Yeah, you're right. And the future of GUI agents is especially interesting because it's so tied to the future of how we interact with computers in general.
Hmm.
We're basically rethinking how we communicate with technology and how we control it.
It's like we're on the edge of a whole new era, and the possibilities are pretty much limitless. But I think it's crucial that as we go down this road, we remember that we're not just building machines. We're shaping the future of human experience.
Couldn't have said it better myself. And to everyone listening, I encourage you to stay curious, stay informed, and stay engaged in this field because it is changing all the time.
Me too. This has been amazing. We've gone from GUI Agents 101 to exploring some pretty mind-blowing possibilities, and now I think it's time to circle back to those training methods and take a deeper dive into how these agents are actually taught to do all these incredible things. Welcome back. Before we went on that whole mind trip about the future, we were about to get into the nitty-gritty of how these GUI agents are trained.
Right. We were just about to unpack those two main methods, prompt-based and training-based.
Prompting seems almost deceptively simple. How do you teach an agent something as complex as interacting with a whole computer interface just by giving it a couple of prompts?
Well, it's not always about teaching entirely new skills. Sometimes it's more about helping the agent apply its knowledge in clever ways. It's kind of like giving someone clues to solve a puzzle rather than handing them the whole solution, right?
Okay, so it's more like nudging the agent in the right direction, letting it figure things out. Can you give us a concrete example?
Absolutely. So there's this fascinating system called Dinosaur, and in this system, the agent actually learns to create entirely new actions by, get this, generating Python code, just by being given a few well-crafted prompts.
Hold on, the agent can write code, by itself. How is that even possible?
Basically, researchers found that if you give the agent a few examples of code snippets that do certain things, it could actually learn to generalize from those examples and create new code for similar actions.
Wow, that's wild. It's like if you showed someone a couple recipes and then suddenly they know how to cook a whole new dish just based on what they've learned. That's pretty amazing. What are some other ways prompting is used in training?
Well, there's a technique called self-reflection, where the agent is basically prompted to analyze its own actions, kind of like it's looking in a mirror and saying, okay, what did I do wrong? How can I do better next time?
So it's not just blindly following instructions. It can actually learn from its mistakes and improve. That's incredible. Any other cool examples of prompt-based training come to mind?
Yeah, we've also got things like state space exploration, where we encourage the agent to just try different actions and see what happens. It's like trial and error, but for AI.
Makes sense.
And then there's expert demonstration, where the agent basically watches a human expert
Yeah.
do a task and learns by mimicking those actions.
Oh, like watching a master at work, learning by imitation. It's amazing how these agents can learn in so many different ways.
Yeah.
But when do we need to move beyond prompting and actually change the agent's underlying model?
That's where those training-based methods come in. These are essential when we really want to fine-tune an agent for a specific task, or just generally improve its performance at a deeper level. It's like we're sending it to boot camp to get those skills sharpened up.
Okay, take us inside this AI boot camp. What's going on in there?
Well, one of the most common approaches is pre-training.
Okay.
This is where the agent is exposed to massive, huge amounts of data to develop a strong foundation in, like the general knowledge and skills it needs. It's like, giving it a broad education before we send it off to specialize in anything specific.
So what kind of data are we talking about here? What are we feeding these AI students?
Imagine showing it thousands, millions of examples of how humans interact with all sorts of different GUI environments. Screenshots of websites and apps, recordings of user interactions, mouse movements, keystrokes, the works.
Wow, that's a lot to process. I'm guessing that takes a lot of computational power, right?
You bet. Pre-training these models, it takes serious computing muscle, but the payoff is worth it. There are models like PX2Struct and C-Click that have been through this process, and they're already really good at understanding how websites are structured, extracting information from images, even predicting what a user's going to do next.
So pre-training is like building that powerful engine, like you said before.
Yeah.
But what about fine-tuning? When do we need to, get really specific and tailor those skills for a particular job?
So fine-tuning, that happens after pre-training. It's about taking that really powerful general-purpose engine and really making it excel at a specific task. We do this by training the agent on more focused data sets that are really tailored to the ins and outs of that specific task.
So like customizing that engine to make it run perfectly in a specific race car.
Exactly. And we've seen some really impressive results with this approach. We've got models like Falcon UI and UI Pro that were fine-tuned on very specific GUI interactions, and they just blew the previous models out of the water when it came to accuracy and efficiency.
That's amazing. It's like they become experts in a particular area.
Yeah, like they know every twist and turn of a specific track.
It's clear that these GUI agents have the potential to totally change how we use technology, but I think it's also really important that we proceed thoughtfully.
You're absolutely right. With any powerful technology, we need to be mindful of the potential impact and make sure they're being developed and used responsibly.
Totally. We need to keep having these conversations about the ethical side of things, the potential risks and benefits, and what it means to integrate these agents into our lives in a way that works for everyone.
Couldn't agree more. It's up to all of us to shape the future of this technology in a way that benefits humanity as a whole.
Well said. And I think that's a great place to wrap up this deep dive. We've gone from the basics of GUI agents to exploring their incredible potential and even pondered some of the big questions about the future. It's been quite a journey.
It has. And to everyone listening, I encourage you to stay curious, stay informed, and get involved in this field because it's constantly evolving and there's so much to discover.
Absolutely. Thanks for joining us, everyone, and keep exploring the amazing world of AI and what it means for our future.